Hello, hello. Can you hear me? Hello, hello. Yes. PUC2 ಸೈನ್ಸ್ ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ, ಗುರು ಹಿರಿಯರಿಗೆ, ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆಯನ್ನು ಸಲ್ಲಿಸಿ. ಟೇಕ್ ಅ ಡೀಪ್ ಬ್ರೆತ್ಸ್. Yes, good morning, my dear students. Today, we'll continue with the study of solutions. In the first part, we just introduced already the types of the solutions. There is introduction part of it. Now we'll continue. Started solving numericals, very important part of it. That is units of expressing concentration of a solution. Units of expressing concentration of a solution. Concentration of a solution. So different units we are using to express the concentration of the solution. Concentration of a solution. We studied so far what is molarity, then studied molality, and studied mole fraction. The formula to get molarity is given by number of moles of the solute. Generally we use 1 for solute, 2 for solute, 1 for solvent, divided by volume of the solution in liter, and solute generally 1 you take for solvent, number 1 you take for solvent, 2 for solute. Wherever I write 1 you think that it is solvent, wherever I write 2 you take it for solute. And this particular number of moles of the solute is given by W2 upon molecular weight of 2, means solute divided by volume of solution in liter is given by, suppose that it is given in centimeter cube, you can write it as volume of the solution in liter. Suppose it is given in liter, divided by liter. How do you convert a liter in cc? Suppose that it is in cc, it is 1000. Volume of the solution in cc, if it is there, then the formula becomes W2 upon M2 into denominator 1000 goes to numerator, you will get 1000 divided by volume of the solution. Remember carefully, What is the formula to calculate molarity? First of all, you note down the formula. And molality. So molality is given by number of moles of the solute, that is N2, divided by mass of W, mass of solvent in kg. Solvent in kg. Suppose that generally solvent is given in grams. Then how do you convert it? That is mass of solvent in grams divided by 1000. Again, number of moles of the solute is given by W2 upon M2. M2 stands for molecular weight. Mass upon molecular weight gives you number of moles divided by mass of solvent in kg, in gram divided by 1000. Generally, they will give you in grams. Therefore, final formula becomes W2 upon M2 into denominator goes to numerator 1000 upon mass of solvent in grams. You can convert it into unit. What is the unit of molarity? Unit of molarity is given by capital M or mole per liter. Mole per liter of the solution. And molality is given by small m, and it is given by mole per kg. Remember the unit of it. Then third one comes mole fraction. Mole fraction. Generally it is represented by the symbol chi. Suppose that chi1 means the mole fraction of the solvent is given by N1 divided by N1 plus N2, means number of moles of the solvent divided by sum of the number of moles of solvent and solute. 2 stands for solute, 1 stands for solvent. This convention you remember. Then the number of moles of the solute is given by N2 divided by N1 plus N2. And if you add chi, this is not x, chi1 plus chi2, that is the Greek symbol. If you take, you will get N1 upon N1 plus M2 plus N2 upon N1 plus M2 becomes 1. Sum of the mole fraction of solute and solvent is always equal to 1. Right? I hope you. Hello, can you hear me? Okay. That is, so far we studied, I will repeat, the molarity is given by number of moles of the solute divided by volume of the solution in liter. And number of moles is given by mass upon molecular weight, W2 upon M2. And volume of the solution, if it is given in cc, then you have to divide it by 1000. Denominator 1000 goes to numerator. Therefore, the simple formula will be W2 upon M2, the 1000 upon volume of the solution in cc. The unit used for molarity is capital M, and or mole per liter or mole per dm cube. Dm cube is also same thing. Never get confused. Second thing is molality. Molality. I hope you are listening me. N2 upon mass of the solvent in kg, remember. And the number of moles of the solute. Generally, we use the convention 2 for solute, 1 for solvent throughout the discussions. Wherever I write 1, you think that it is solvent. Wherever I write 2, you consider it as solvent. Now, number of moles of the solute is given by N2 upon mass of the solvent in kg. Again, number of moles of solute is given by W2 upon M2 divided by mass of the solvent in grams. Sometimes it is given in gram. To convert it into kg, or to divide it by 1000 grams. 1000 grams means equal to 1 kg. These many grams is equal to how much? Denominator goes to numerator. You will get W2 upon M2, 1000 upon W2 upon solvent in kg. The unit used is small m, and mole per kg is SI unit. And mole fraction. Suppose that there are two components. One is solvent, two is solute. Mole fraction of the solvent is given by number of moles of the solvent divided by sum of the number of moles of solvent plus solute. 1 solvent, 2 solute. Have this convention in your mind. Mole fraction of 2 means solute. N2 divided by number of moles of the solute divided by number of moles of the solvent plus number of moles of the solute. Keep these things in your mind before you continue with the numericals. So numericals in this particular chapter is very important. And before we continue with the numericals of first level, very important numericals. This is a numerical based chapter. We'll see another unit, fourth unit, is called as percentage. Percentage. So what is percentage? Percentage means amount of the solute. Amount of solute present in 100 units of solution. 100 units of solution. As I discussed in the previous class, this percentage will have three types. Percentage of mass upon mass, percentage of volume by volume, or percentage of mass by volume. There are three types. Mass divided by volume. And what is the formula to get the percentage? Mass by mass is given by mass of solute divided by total mass of the solution. Total mass of solution. Percentage means into 100. Similarly, you can define percentage of volume by volume is given by volume of solute divided by total volume of solution. Total volume of solution into 100. Then third one is mass. Percentage mass by volume is given by mass of solute divided by total volume of the solution. Total volume of solution into 100. You remember this formula correctly. And another unit we expressed is parts per million. Means amount of the substance. Amount of solute present in 1 million means 10 raised to 6 units of solution. Therefore, parts per million is represented as mass of solute mass of solute divided by total mass of solution, total mass of solution into, like you take for percentage you are taking 100, for million you are taking 10 raised to 6. Generally, whenever small quantity, very small quantity like pollutant in the air, very small quantity is present, then you are using this particular unit. This particular unit called as parts per million. Okay. Now, with this we will move on to the numericals. Level 1. Very important part in this chapter is the calculation of the units. We'll see some questions, level 1 questions from the textbook, NCERT. Then we'll see some competitive exam questions, NCERT. Let us take the problem. Some in-text questions. Calculate the mass percentage of benzene. Calculate the mass percentage of benzene, with the formula C6H6 and carbon tetrachloride it is formula CCl4. If 22 grams of benzene is dissolved in 122 gram of carbon tetrachloride is the question. Okay, let us solve this problem. Calculate the mass percentage of benzene and carbon tetrachloride if 22 gram of benzene is dissolved in 122 gram, which is in large quantity, is taken as solvent. Therefore, here in this problem, which is a solvent? It is mass of benzene can be taken as W1. Benzene is I think solute W2, which is 22 grams. Then mass of carbon tetrachloride, mass of CCl4, we will take it as W1 because it is taken in large quantity. Therefore, 1 stands for solvent, 2 stands for solute, so that your calculation becomes easier. Okay, no problem. Now, what is the formula to calculate mass percentage, mass by mass percentage? Right? Percentage by mass of a benzene. If you want to take, the formula is mass of the solute W2 divided by total mass of the solution, that is W1 plus W2 into 100 is the formula. To get percentage of benzene, you can substitute the value of mass of the solute W2, which is 22 divided by sum of the mass, total mass of the solution. Solution consists of both solute as well as solvent. Therefore, you will get the answer, that is 22 plus 122 into 100. Here you can get 22 divided by, what is 122 plus 22? Is it not 120 plus 21, 44 into 100. 2200 upon 144. We will just divide it to save time using calculator. 2200 divided by 144 gives you 15.2 8 grams. The mass percentage of this is the percentage, sorry, mass percentage of benzene. And what is the mass percentage of percentage mass by mass of percentage mass by mass of carbon tetrachloride can be easily obtained by subtracting 100 minus 15.28. You can subtract 100 minus 15.28. You can calculate 100 minus 15.28. We'll get the answer as 84.72 percentage. So that is the solution. May appear for 2 marks. I hope you understood the solution. Have the convention 1 for solvent, 2 for solute. Right? Take the second problem. Okay. The second problem will be, continue. The second problem. Calculate the mole fraction of benzene. Question is, calculate the mole fraction of benzene in solution containing 30% by mass of 30% by mass of 30% by mass in carbon tetrachloride solution. Calculate the mole fraction of benzene in solution containing 30% by mass in a carbon tetrachloride solution. Here, which one is considered as solute and which one is considered as a solvent? Let us take solution. By mass means mass of benzene here you can take it as 30 grams, that is say W2, because it is solute, is 30 grams. This convention will help you. So mass of carbon tetrachloride, which is a solvent, which is W1, will be definitely 70 grams. Now what you have to calculate to get the mole fraction? You need to get what is the mole fraction of solute. Solute is W2 is equal to N2 divided by N1 plus N2. Therefore, you have to get what? Number of moles of the solute. How can you get N2? N2 is given by W2 upon M2. What is the W2 here? Here the W2 is 30 grams. Molecular weight of the benzene C6H6. Calculate. Atomic weight of carbon is 12. 12 into 6 plus 1 into 6. 12 6 are 72 plus 6. You will get 78. Therefore, divide by 78. If you divide 30 by 78, 30 divided by 78, you will get 0.384 moles, number of moles. Similarly, you can get N1 is equal to, N1 is number of moles of solvent, that is W1 upon M1, carbon tetrachloride. Calculate molecular weight of carbon tetrachloride, which is carbon is 12 plus 4 into 35.5. You can add it, 12 plus 4 into 35.5 gives you 154. So mass is carbon tetrachloride, molecular weight is 154. What is the mass? 70 divided by 154. Now divide 70 divided by 154 gives you 0.4455. You can take approximately 455. Okay, 454. Okay, no problem. Now what you are asked to calculate is mole fraction of benzene. So mole fraction of benzene can be calculated by taking number of moles of the benzene, which is 0.384 divided by mole fraction of the solvent is 0.454 plus 0.384. That is 0.384. Add them in the denominator. You can add 0.454 plus 0.384 will be equal to 0.838. If you divide it, mole fraction of the solute benzene, mole fraction of the benzene is given by dividing 0.384 divided by 0.838. You will get 4.582 will be the mole fraction. Mole fraction will be generally unitless. 0.4 into 100 mole fraction. No, not necessary. Mole fraction. Number of moles of the solute divided by sum of the number of moles of the solute and solvent. We got it as 4.582 is the mole fraction of the benzene. Check your answer. Calculate the mole fraction of the benzene. Mass of benzene is taken as solute 30 grams. Carbon tetrachloride is 70 grams. Number of moles of the solute is given by 30 upon 78. 30 upon 78 gives you 0.384. Then the number of moles of solute is given by N1 is given by W1 upon M1. 70 upon 154 gives you 0.454. Molecular weight will be 154. 12 plus 4 into 35.5 comes out to be 154. You can take now 70 upon 154 gives you 0.454. The mole fraction of the solute is obtained by N2. N2 is mole fraction of benzene divided by sum of the mole fraction of both of them will be 0.838. You will get 4.582 will be the answer. Okay, continue with the third problem. Third problem. See how you can solve the problems on mole fraction, molarity, right? So this is very important. Numerical area is very important. Okay. We'll continue with the next problem. Solutions. Problem number 3. Calculate the molarity. See the problem. Calculate the molarity. Calculate the molarity of each of the following solutions. Of each of the following solutions. Following solutions. each of the following solutions. In that A is 30 grams of cobalt nitrate hexahydrate, cobalt nitrate CONO3 twice cobalt nitrate dot 6H2O in 4.3 liter of solution. 4.3 liter of solution. B, in this I am solving in text questions. 30 ml of 0.5 molar S2SO4. You have to calculate the molarity. 30 ml of 0.5 m S2SO4 diluted to 500 ml. Okay, no problem. Look at here. Study the problem correctly. Calculate the molarity. First of all, we will see one by one. Molarity of the solution A. 30 grams of cobalt nitrate solution means cobalt nitrate, that is mass of cobalt nitrate CONO3 twice dot 6H2O. It is a solute. Therefore, let me take it as W2 is given as 30 grams. Okay. To calculate molarity, you have to calculate what number of moles of the solute N2 we need. What is the mass of the solvent? 30 grams of. What is the volume of the solution? Volume of solution is given as V in liters is given as 4.3 liters. There is no problem, already volume is given in liters only. Now to calculate number of moles of the solute, N2 stands for solute. Solute means cobalt nitrate, is given by W2 upon M2, where M2 is molecular weight of cobalt nitrate. You have to calculate this thing, CONO3 twice 6H2O. Let us calculate the molecular weight. Atomic weight will be given to you. It is 58.7. Atomic weight of cobalt is 58.7 plus 2 into bracket. There is nitrogen is atomic weight is 14 plus 3 times atomic weight of oxygen plus 6 times atomic weight of water. 16 plus 2 is 18. Calculate the molecular weight. You must improve your calculation. 2 into calculate. 16 3s are 48. 48 plus 14 is 58, 62. You add, right? 40 plus 10 is 50. 58 plus 4 is 62. Plus 18 6 are 18 5s are 90, 108. So simplify, you will get 58.7 plus 62 2s are 120, 124 plus 108. Add them, you will get 58.7 plus 124 plus 108. You will get 124 plus 108. You will get 290.7. 290.7 is the molecular weight, gram molecular weight of it. Therefore, you can get N2 is equal to, what is the mass of the solute is 30 divided by, number of moles of the solute is, what is the formula for molarity? Yes. Molarity is given by the formula number of moles of the solute divided by volume of the solution in liter. Volume of the solution is given, number of moles, just now you got it as 290, what is the mass of the solute? Number of moles of the solute. You calculate number of moles of the solute. You got number of moles of the solute, that is N2 is given by W2 upon M2. Just now we calculated molecular weight. So N2, you can get it as, what is the mass? What is the mass given to you? Mass of the solvent is 30 gram. You take 30 here divided by molecular weight of the solute. Molecular weight of solute is 290.7. 290.7. Therefore, number of moles of the cobalt nitrate is given by, let us divide 30 divided by 290.7. You will get 0.103. 2 you can take, round it off, you can take 2. You will get now 0.1032 divided by volume of the solution in liter. What is the volume of the solution in liter is given as 4.3 liter. Now divide it, you will get the molarity. That is 0.1032 divided by 4.3 comes out to be 0.024 m will be the molarity of the solution. Observe, clarify the doubts. Will be the answer 0.024. Then second part. I hope you got the answer. First of all, you note down the data. Volume is already given in liter, and molarity is given by number of moles of the solute upon volume of the solution. Volume of the solution is very clear here. Volume of the solution is very clear. VL is given as 4.3 liter. This problem is over, but only you have to calculate number of moles of the solute. To get number of the moles of the solute, what we need is mass of the solvent. 30 already knows, but you have to calculate the molecular weight of the W2 M2. Cobalt nitrate 6H2O. Cobalt molecular weight, they will generally give 58.7, and on calculation you will get 290.7 grams. And now you divide 30 upon 290.7, you will get N2 is equal to 0.1032. N2, therefore molecular weight is equal to N2 is 0.1032 is substituted, divided by 4.3, you will get the molarity is 0.024 m. I hope you understood the first part of it. I hope you noted it. You continue with the second part. Second part is very easy, because what you are given with here is 30 ml of 0.5 m H2SO4. There is a formula. M1 V1 is equal to M2 V2. Observe, 30 ml of 0.5 m H2SO4. 0.5 into volume is 30 ml is equal to M2 into, when it is made into 500 ml, you can write 500. Now you can easily get M2 is equal to 0.5 into 30 upon 500. You studied already. M1 V1 is equal to M2 V2. So 0, 0 cancels, right? Even you can cancel this point also to get another 0. 5 ones are, 5 ones are. You will get 100. 3 upon 100 will be, M2 will be 0.03 molar. 0.03 molar should be the answer to the third question. Check. Clarify the doubts. This is the problem. Number 3. Take next problem. Hope you understood the problems. Fourth problem. Calculate the mass of urea. Fourth question. Calculate the mass of urea. The mass of urea with the formula NH2CONH2. Urea has got the formula NH2CONH2. Required in making mass of urea required in making 2.5 kg 2.5 kg of 0.25 molal m aqueous solution. Aqueous solution means solution in liter. Aqueous solution. Problem is easy. You can collect the data now. Calculate the mass of urea. Calculate the mass of urea required in making 2.5 kg of 0.25 m. So here molality is given. First of all, you collect mass of the urea. First of all, you collect. Whenever you come across statement problems, collect the details. What you are given with required in making 2.5 kg. 2.5 kg, that is a mass of urea. Mass of urea. Urea is a solute here. Therefore, let me take a W2 by convention as 2.5 kg. Of what is the molality is given? Molality is given as 2.5 kg of solution it is. 2.5 kg required in making 2.5 kg of 0.25 m aqueous solution. 0.25 m aqueous solution. Molality is given by 0.25 molal. What is the formula for asked? What you are asked to get? You are asked to get this is a mass of the solution. This is the mass of the solution. Just observe here. Mass of the solution is given by mass of solute plus mass of the solvent is given by 2.5 kg. This you understand clearly. Okay. Calculate the mass of urea. Mass of urea required in making 2.5 kg of a 0.25 m aqueous solution. You are asked to get mass of urea. Urea means W2 question mark. Aqueous solution means it is present in water. Are you getting me? And what is molality is given by? Molality is given by number of moles of the solute. Number of moles of the solute. Number of moles of the solute divided by mass of solvent in kg. Mass of solvent in kg. Are you getting me? And this particular number of moles of the solute is given by what? W2 upon M2 divided by mass of solvent in kg. They are given in kg only. Some of them. Mass of the solvent in kg is W1. Mass of the solvent in kg. Try now. Take 1 or 2 minutes. Okay. Now, first of all, you try to get 0.25 molal. What is the meaning of 0.25 molal? 0.25 molal means how many moles are it? What is the molality? 0.25 molal means 0.25 mole of urea in 1 kg of water, because it is aqueous solution. Now you can get the details now. What is the number of moles of the solute? Number of moles of solute is given by N2. Number of moles of the solute is, that is urea is 0.25 mole per given with. And what is the mass of the solvent? Mass of the solvent W1 is water here, which is 1 kg. Are you getting me? What is the number of moles is given by? Number of moles is given by W2 divided by molecular weight of the solute is equal to 0.25. Number of moles, 0.25 moles. Now, what is the molecular weight? Can you tell me molecular weight? Molecular weight of urea, NS2, that is the molecular weight of the solute. M2 is obtained by taking urea NS2CO. There are two nitrogen, NS2, CO, NS2. Let us calculate how many nitrogen atoms here. Two nitrogen atoms, each having atomic number 4, plus one carbon atomic number 12, one oxygen atomic number 16, and 4 hydrogen. Now you can calculate 14 to 28 plus 12 plus 16, you will get 28 plus 4. 28, 56 means 60 grams. Therefore, you got M2 as 16 grams. Therefore, mass of the solute is given by, upon M2 is 60, is equal to 0.25. Therefore, W2 you got it as 0.25 into 60. Got a 25 6 25 6 150 00, you will get 15 gram, or 15 gram is the mass, and urea is 15 grams. Now you can get the mass of the solvent present in it. What is the mass of the solute and mass of the solvent? Mass of the urea in it is, mass of the urea, calculate total mass of the solution. Whatever asked to calculate mass of the urea required in making 2.5 kg of 0.25 m molal. You got now. Mass of the solvent is 1000 gram. That of solute is 15 gram. Total mass of the solution is, total mass of solution is equal to 1000 gram, that is W1 plus W2. W1 is 1000 plus 15, you will get 1015 grams. You can express it in kg. 1000 plus 15 grams, you can get it as 1015 grams. You can express it in kg as 1.015 grams. Are you getting me? Now, how can you get to make a 2.5 kg, right? To make a 2.5 kg, right? To prepare 1 kg solution, right? 1025 grams, sorry, 1.025 kg. Convert this gram into kg. Shift 3 decimal points to the left. Now you can get, calculate the mass of urea required in making 2.5 kg of 0.25 m aqueous solution, right? 2.5 kg. How can you get 1.015 kg? 1.01 kg, 1.015 kg of solution contains how many grams of urea? Mass of the urea is 15 grams, or you can say 0.015 kg. Then to prepare 2.5 kg of solution, what is the mass of urea required is asked. See that the difficulty level of the problem. Therefore, mass of urea required is what you get? You get in the denominator 1.015. In the numerator you have 2.5 kg into 0.015 kg. You just calculate it, you will get the answer. The answer will be 2.5 into 0.015 divided by 1.015. You will get the answer is 0.0369 kg. 0.0369 kg. Or you can write it as in grams 36.9 grams. 36.9 grams, or you can round it up to approximately, you can take it as 37 grams will be the answer. Check your answer. Okay, I will just analyze you. Try this problem. I'll give few problems to solve as homework. Then I will solve them in the next period. Take this one, fifth one. Calculate A, molality, B, molarity, C, mole fraction of potassium iodide if the density of 20% is homework to you. You try them. 20% is mass by mass, W by W, aqueous potassium iodide is 1.202 gram per milliliter or cc. And second homework is you can solve the problems given in NCERT textbook, exercise 1.4. You try 1.4, 1.5, 1.6, 1.7, 1.8. You try them. I will solve these questions and complete this particular thing. That will prepare you smoothly for the exam. That's all, my dear students. The calculation based on concentration will not be easy. You have to carefully analyze them, apply them. Lot of skill is required to solve these problems on concentration. If you improve this, then your application ability will go on improving, right? So tomorrow is Saturday, and I will let you know at what time I am going to take the class. Mostly tomorrow morning, Saturday morning, it is not possible for me because I have to migrate to Gadag. I will announce you. Mostly I will take it on Sunday. Okay, Sunday I will try to manage. Otherwise, I will inform you. Then we will continue on Monday only. Okay, I will just let you know, right, in the WhatsApp group. And till then, bye bye.